All right, so now we're going to be talking about changing an exponential function. So we've seen how to compute a constant rate with linear functions. Now we're going to see what happens when our output value changes proportionally. Changing proportionally means that I am multiplying by the same rate of same factor every single time, right? So up first here, we have our table. It says use the graph of the sequence shown at the right to complete the table below. So we have in N1 we get 64, at N2 we get 32. How can I find the difference here? Well, not the difference, the ratio. Huh? What did she say? What is happening? How am I going from one A sub N to the next? What did I do? Okay, remember it's going to be something we multiply by. What am I multiplying by? If I divide by 2, then that's going to be what? Multiply by a half. So to get from here to here, we'd have to multiply by 1/2. Remember, me in the copier didn't get along. It's weird. Yeah, it just folds the other way. I've already discussed that I messed up. Thank you. Thank you.
No, what I don't like is when it's on all four sides, because then you have to glue it.
Actually, I like this one.
Well, a happy accident, guys. A happy accident. So continuing this, multiplying by a half, right? How I printed it? Like a booklet where it folds and then... Thanks. All right, what is 3? Stay on track. 16. What is 4? What is 6? And what is 7? And if I wasn't sure what I could use to help me, there's a graph. It's going to have an asymptote, okay? Leading us to exponentials. Do exponential functions have horizontal asymptotes? Yes, they do. All right. So we're going to write our common ratio, okay? And explicit. So the model is A sub n equals your initial A's, and I'm going to modify it here in a second, times your ratio to the n, okay? This is initial 0. That's if you have 0. Do we have a 0 term? No. A sub, yeah. It's a closed 0. What do you mean?
Okay, that's a bigger dot.
Is that what this is used for?
Huh?
This don't apply to the yearly rate question.
Exponential models? Yeah. All right. So this is our model that we're using, correct? However, we don't have A sub 0. Could we like figure out what it is? Yeah, by multiplying by 2, right? But that we don't have to. As long as we adjust our n, we can adjust our A sub 0. Does that make sense? If we adjust our n, so if I can change this by, so I have A sub n, but I have to start off with 1, and I know the value of 1. The value of 1 is 64. I know my rate. What is my rate? What's our R? We multiplied by a half to get from one thing to the next. And so I show that I did not start out 0 by putting it as n minus 1. The same thing that we did with linear, we're going to do with exponential. So if I'm not starting at A sub 0, I show that I didn't start at A sub 0 by making that clear in my power. If you want to find the initial, yes, you can. I'm not stopping you from doing that. I'm just showing you that you don't have to do that extra step as long as you just show that you are not starting at the initial. So you remember how in our example on number 7, we didn't start at 0, did we? No, we started at 11 and we started at 19. But we made that clear in our function models, correct? As long as you're making it clear that you're not starting at that A sub 0, then it's the same thing. Got it? All right. However, if we were to start at A sub 0, what do we end up with? 128. Do I care which one you give me? No, I just need you to understand that they are the same. Got it? All right, so now that once you have a model, it wants you to just turn it into a function model. And literally to turn it into a function model, all you're doing is going from writing a sub n to writing f of n. That is all it's asking you to do. F of n equals 64, 1/2, n minus 1. Or f of n equals 128, 1/2 n.
Oh. They wrote down A and then-
Huh? If it asks for the function and you write a of n, then you're wrong.
Yeah, come on. Ask questions wrong.
Right, then.
Okay? Because it's asked for the function model, not the explicit rule. Okay? All right, how we feel?
No, is it supposed to be n minus 1 on the second equation?
No, because we started at A0. Like A0 would be 128. Yeah. Do we understand where the 128 came from? Are we all good with that? Okay. All right. Is it terrible? It's not, is it? I know you want it to be, but it's not. Okay. Good? Yes. Ready for the FRQs? All right. So on here, we have that a sub 1 is 154, a sub 3 equals 36, and it wants us to state the domain and range and fill in the table, okay? So we got to figure out what's missing, what are our values. I'm going to give y'all a moment to productively struggle.
Miss Chelsea, you please
Okay.
help me, please.
I want you to think about how can I find out what's missing?
Maybe it's slope from 144.
It's not slope because it's not linear.
Oh, yeah.
Quadratic. Can you give us number two?
2, 36, 18, 9, now we're gonna do 2, right?
You gotta write that
Okay.
all.
No, it's
All right. All right, so here we go. This one was actually like friendly numbers, right? So if you kind of just through it. What's given here is 2 points. You need 2 points to be able to solve this. The first point is going to help you create your equation, okay? So from our given point of A1, we know that our equation would be 144 times some r to the n minus 1. Does that make sense? Okay. From our next given value, where'd it go?
No,
There we go. There we go. A sub 3 equals 36. That's what we're going to use to solve for what our R value is. Does that make sense? Okay. So if I know that A sub 3 equals 36, so A sub 3 equals 36. 36 equals 144 to the R 3 minus 1. Okay. The reason why it's 3 minus 1 is because what is our N value? 3. And so it's 3 minus 1. So now all you're doing is solving this. So you're left with 36 equals 144 times r squared. Can I solve for r from there? Yeah, what do I do to solve for r from there? So I'm going to divide by 144 and then do what? And then take the square root. Does that make sense? Okay. And then from there, I will then know what I'm multiplying by to get my value. Yes? So our r equals what? R equals 1/2.
I knew I was smart.
So now I can figure out the rest of the values. So we have 72, we have 36, we have 18, we have 9, and we have 9/4. Okay? These represent our range, and these values represent our domain. Agree? Okay? They're giving you enough points. All you need is 2. You don't even need the third one to find your pattern. If you productively struggled and figured out before I start talking, give yourself a round of applause. That's it. So final round of applause. Okay.
Productively struggle.
Did you productively struggle? You erased it? Okay. All right. All right. So in total, we're now going to write, and number 10 and number 9 go together. Now we're going to write our function model. Remember, function model means that I'm using what? F of n. So our f of n equals what? 144 times 1/2 to the n minus 1. Yes? Okay, if you want to write it as a sub 0, could you? What would be the a sub 0 one? There we go. Perfect. Remember, these are the same. Agree? How are we feeling?
Good, we're surviving.
We're surviving. Okay, I'll take it.
Okay, we're good.
We're good? Okay. Why not? Okay. All right. So we're going to go on to number 11. What happened? Oh, I thought you were being funny. I don't know when to take you serious. All right. This chisel jackhammer is going to drive me insane. It's out to get me. I've been here all morning. It's been doing it all morning. All right. Do y'all not see how it's vibrating my board?
Yeah.
You don't see it?
I see it now.
I know you see it. I know y'all see it. It's okay. All right. So our explicit formula for the end term of a geometric sequence is a exponential model. Oh my God. Look at all that coming together. Who would have thunk it? You did. We did. Right? We saw that? No. There's nothing right. It's just the part that I want to make sure. Yeah. I just want to make sure we came to that conclusion, right? So arithmetic is modeled by what? And geometric is modeled by exponential. We see it? We got it? Stop playing with my emotions. You see I'm already on the edge with this. I'll let you say yes, no. I was like, don't do this to me. You really ready? All right. Okay. So, sorry for making y'all point that out. And clearly, just by looking at it, when I'm plotting these points, can I not see what type of function is being created? Yes, I can. What function is being created? Exponential. This is an exponential model. This time what they want you to do is go from a graph to a table and create your explicit rule and your function notation. Is that something that we can take 2 minutes to do at our tables? Because I believe in you. Okay? Yes. No, we're going to stare at each other deeply. No.
Yeah. How are we supposed to know where they're at?
Yeah.
Let's see. Should I tell y'all? Let's see.
I don't know why they would make you graph.
Wait, are the Y values on the top right there? The 3, 6, 12, 4? Okay, yeah.
It's right underneath. Does that help? 90. Oh, I don't know why I kept getting smaller. So what's going up?
24, 48, and 96.
I don't know why I decided to get tinier as I was writing up the exponential function. Can you see them? Huh? You're in? It's where they're at. These are your ends right here, Alana. In is your.
It's party in the USA.
It's times. Oh no.
What do you mean?
Dots?
Oh yes.
So at term 1, I have 3. At term 2, what do I have, Alana? So what are you asking me? Oh, this part? Oh, anything.
Oh, okay.
Oh, I thought you meant like what's in. I was like, Alana.
Yeah, no. I was trying to figure out what.
Oh, what the end game is. Okay, got it. I thought I was tripping. So our terms are first one at term number 1. Our output was 3, and we would write that as subscript A1 equals 3 or F of 1 equals 3. See that connection? Because that's what the term is. So A sub 1 equals 3, F of 1 equals 3, correct? All right, on term number 2, what do we have? 6. So A sub 2 equals 6 and F of 2 equals 6. At 3, we should have 12. So
No. Yes.
I was like, what?
I was thinking 3, 6, 9, 12.
Oh, okay. At term number 4, we have 24. So A sub 4 equals 24 and F of 4 equals 24. At 5, we should have 48. So A sub 5 equals 48 and f of 5 equals 48. And I know this sounds repetitive, but it's to make sure that you understand that explicit rule and function notation are essentially the same. Are we seeing that? Have we accepted that as true? It's like, I'm sensitive right now. All right, so our subscript notation is the same thing as an explicit rule. What is our explicit rule that we're following? That would be our a sub n equals what?
Oh my gosh, 3.
Uh-huh.
2.
Uh-huh.
To the n minus 1.
Perfect. In this case, it's a little bit easier to just write it as n minus 1 than trying to find the 0, right? And then our function notation, f of n would equal the same exact thing, guys. The same exact thing. Explain to me why. I don't know. I just follow the rules of the CDC.
I'm sorry.
Yeah.
I don't want to confuse anybody.
Yes. Okay.
They do this one with, like, you find, why is this one different than the other one where we found?
Because now they're making the connection to it being an exponential model where the other was just focused on it being a geometric sequence.
Gotcha.
Yep. Of course. That's why I'm not paid the big bucks for. All right. So here we go. Just utilizing the rule. Are you comfortable using the rule? Is what it's asking you. So if I asked you to find the first 6 terms of the sequence, can you comfortably find the first 6 terms of the sequence?
Yeah.
Go for it. Find the first 6 terms of the sequence.
I ruined my plan.
No, I cannot help you. I cannot assist you in this matter.
Do you know what portions of the AP exam was getting calculated?
They give like a kind of a breakdown, but we got our final, what do you call it? So we'll, in January, after they've done all the analyzing of tests and all that, they should give us kind of like a general breakdown of these types of questions will be calculators. Like these types of questions will be non-calculator.
They tell you that, are we gonna like go over everything?
Yeah. So as we get closer to preparing, like the last 3 weeks out, should just be pure review. And as we get closer to that, May 13th. Yeah, what? On a Tuesday?
Actually, no.
You're right.
May 13th at 8 a.m.
It's the other people.
I actually had a cluster on the AP US.
This is a really random question to ask your teacher.
But what happens if we don't take the exam? The AP test?
You have to take it. No, I'm playing. I don't know.
Are you doing midterm exemptions?
They haven't sent out the exemption rules yet, and if we're having them or not. So I don't know.
Just so I can get that exemption?
Yeah.
Seniors.
Seniors, it should apply to seniors.
Should be able to get an exemption in the fall if you have 2.
You can have 0 unexcused and 2 excused.
Oh, I'm cooked. I
They-
have 2 excuses.
Yeah, you cannot have 3 absences.
Yeah.
For any
What
reason.
did you do?
To be exempt from the
Right,
mid.
unless they have an S next.
Yeah.
I'm cooked.
Seniors, but what's an exemption?
The juniors, I don't think have any fall exemption.
No, it's only senior exemptions unless they change it. But
What?
We're so mad at this. You can't miss
Sorry.
it.
Exemptions will kill y'all in college. You should